Hello, welcome to this video on configuring remote access services and network policy services in Windows Server 2012 R2. These topics will be of particular interest for those of you studying for the 7411 MCSA Server Infrastructure Exam. These videos are not intended as a comprehensive, in-depth look at configuring technologies. Instead, they're designed to give you an overview of the components required, in particular emphasis on those technologies you need to understand before you sit Microsoft certification exams. In this video we'll be using 3 virtual machines. One virtual machine has been installed with Windows 8.1 and will act as our test workstation, at present sat out on the internet without any connectivity. I then have a server, RAS1. This RAS1 server has been installed with the remote access server role, but it has not been configured. My second server, DC1, is acting as my domain controller and my network policy server. The network policy server role does not have to be installed in the domain controller, but to keep my number of virtual machines down to a minimum, I've installed the NPS on the same virtual machine as my domain controller. Now, like I said, the workstation machine at the minute has no network connectivity, so we'll start off just by proving that there's no network connectivity before going on to configure the remote access server. So we'll start off by logging on to workstation 1. As a user Bob, if we access the desktop and then just take a quick look at our network settings. So as you can see here, I have an Ethernet connection and a disconnected VPN connection. Now this VPN connection has been configured with default settings using PPTP as its VPN protocol. Now at present, if I try and connect this VPN connection, we see it trying to connect to the VPN server, and very quickly we should see that this times out. Very quickly we should this times out. There you go. The network connection between your computer and the VPN server is interrupted. This can be caused by an whole series of problems there. Now the reason we can't connect to my VPN server is because the VPN server is not configured yet. So what we'll do is connect to the VPN server and look at the configuration of the remote access server elements. So here we are on our remote access server 1. As you can see, the remote access role has been installed, but the service is yet to be configured. If we right click on RAS1 local and say configure enable routing and remote access, now at this point we can follow one of the basic wizards through configuring VPN, NAT, or NAT and VPN services. I'm going to say custom configuration, and I'm going to say VPN access and leave everything else unticked. Now this one tick box will go through, and once we start the service, configure a basic configuration of our remote access server. And before moving on, we will take a look at a couple of elements that are configured for us. So we're going to start off by looking at the properties of the remote access server. Here we can see that it's acting as an IP4 remote access server. We haven't enabled IPv6, but everything that we're going to configure in the next section is applicable to IPv6 as well. It's also acted as an IP4 router. If we look at IPv4, we can also see that IPv4 forwarding has been enabled, and that we're going to assign IP addresses from a DHCP server. And a little warning with DHCP configuration: if you find that your clients are receiving a DHCP address but they're not receiving option information, make sure you install a DHCP relay agent on your remote access server. We can see that login is enabled to log events to Event Viewer as well, logging both errors and warning messages. Now by default, when we run through the remote access server wizard, it will configure ports to allow connections from the four main VPN protocols: SSTP, PPTP, L2TP and IKE version 2. If we want to install additional routing protocols or configure network address translation or indeed configure our real agent, we do all of that beneath the IP4 node. Now with the remote access server started, we may think that we've now be able to connect from our client machine. But again, if we now flip back to our client machine, even though the remote access server started, we still cannot connect. This time it says error 8112, the connection was prevented because of a policy configured on the RAS VPN server. So our connection is still not allowed. So just running through the wizard on the VPN server and enabling VPN services is not all we have to do. You see, as well as configure authentication services, we also need to configure authorization services on our remote access server as well. If we refer back to our PowerPoint slide, as said previously, RAS1 is providing the VPN services for the client. RAS1 is domain joined. Now RAS1 has got no idea about the usernames that have been presented to it from the client machines. So RAS1, being a domain joined machine, will send authentication requests to your domain controllers. And the domain controllers can use the Active Directory domain database to determine whether your user account has access or not. Now in this case, Bob is a domain user and will have presented correct credentials. That information will be verified against the Active Directory database and the results passed back to our RAS server. But now our RAS server has to look at those credentials and make a determination of whether you are authorized to use VPN services or not. To do this, by default, all users' connections, in fact all connections coming into the VPN server, are checked against a set of local policies called network policies. These network policies exist on each remote access server. So if we flip back to our remote access server, we can take a look at these network policies. So back on remote access 1, in previous editions of Windows operating system, the remote access server network policies used to be configured directly through this console. Today, if we select remote access and login policies, we see it's a message saying that you can no longer configure the policy through here. Instead, we have to launch NPS. Now this is where things can be a little confusing. On this remote access server, I've not installed the network policy server role, but yet we have the NPS local console. When you see the NPS local console, but you haven't installed the NPS role, you are looking at local policies of this remote access server. If you had 10 remote access servers and you want to configure policies on each one, you have to open this console 10 times, once on each machine, to configure the local policies. Now there's lots of things going on here, but what I'm interested in is the network policy section. And inside here we'll find two network policies. Both of these policies have the effects of similar effects. They both deny access 24 hours a day, 7 days a week. Now if we take a look at one of these policies, if I right click and got the properties of policy, network policies are made up of three different elements. First of all, conditions. Now the conditions of this default policy say 24 hours a day, 7 days a week. So 24 hours a day, 7 days a week, that is condition. If those conditions are met, then we are going to deny access. Deny access. Now if you think about this, if a connection comes through from a client machine, the user could potentially be authenticated against Active Directory, but these network policies now are saying that even if that user is valid, if it is a day of the week and an hour in the day, that user will be denied. So what we need to do at a very minimum in order for users to be able to connect in to our VPN servers is to configure one network policy that adds a condition that matches our user's connection. Now we'll start off by saying new network policy, and we'll call this policy policy 1, and we'll add a condition. So my condition will be Windows group membership, and I will say that if the user is a member of the WBL staff group, so if the user is a member of the WBL staff group, and we'll add a second condition based on date and time. So say if the user is in this group and it is between 7 and 8, so between 7 in the morning and 8 in the evening, Monday to Sunday. So if these conditions are met, then grant access. Conditions, permissions. If these conditions are met, then grant access. If the permissions are met and the user is granted access, then we can configure the rest of the constraints or profile settings that go to making the rules for this connection. So if the conditions are met and the user is granted access, they will be only allowed to access if they use one of these authentication methods. If the user is granted access, they will be allowed to connect, but they will only be allowed 20 minutes of idle time. They'll be allowed to connect, but they will only be allowed maximum connection time of 1 hour. So conditions are met, permissions are granted, based around the constraints of the policy. Conditions, permissions, and constraints. Now, with our policy in place, we would think now that our client will be able to gain access. Bob is a member of the WBF staff group. At present it is 3 in the afternoon, so I'm logging in or trying to log in during that time. But again, if we flip back to the client and see if Bob can gain access, so back on our client, if we say connect and disconnect, and we try connecting, error 629, the connection was closed by the remote computer, so we still can't connect even though we've got an appropriate policy. Now this comes back to one of the sort of fundamentals of how policies are processed in root remote access. If we go back to our remote access server console, so here back on our console we can see the processing order of the policies. Now remote access policies are processed from top to bottom. As soon as a policy matches your connection type, your connection conditions, then that policy is your policy. Now I've already said that the default policies deny access 24 hours a day, 7 days a week. So as it will always be an hour in the day, and as it will always be 1 day in the week, then as soon as these policies are checked, that's your policy, it matches your conditions, so therefore you are denied access, and policies lower down the list are not checked at all. However, if I move my policy up the list and change the processing order, now the first policy that's checked when a VPN connection comes in is policy 1. This says if you remember the Y Boston Lake staff and it's one of these date and times, then grant access. So let's just see what happens now when our user tries to connect in from workstation 1. So here back on workstation 1, if I say connect and disconnect and choose to connect, This time, connections established. Now bear in mind I've configured this VPN connection. It's using the credentials that I'm logged in with to fire at the VPN server. It may be the first time that you connect, you are asked to provide a domain name and password in order to start the connection. So, what have we done so far? Well, so far we have done two things. The first thing we did was install and configure the Remote Access Server role. I'd already installed the role feature, but then we used the root Remote Access Console to configure the wizard to start the service as a VPN server. The second thing we did was configure a network policy on our Remote Access Server. Now remember, network policies are made up of three things: conditions, permissions, and constraints. My policy, policy 1, was made up using two conditions: the Windows group membership and the date and time condition. Do remember that all conditions in a policy have to be met before that policy applies to your connection. My policy then granted access. The only other permission we can give through policies is denied access. And then come the constraints. If a policy matches your connection, if the conditions in that policy match your connection, and the permissions grant access, then the rest of your connection is framed by the constraints, which control how long you can connect, how much idle time you can have, the encryption time you can use, as well as a whole host of other connections. If I was studying for the 7411 exam, I would make sure that I spent some time viewing the various conditions and various constraints that make up network policies. Now, our network policy exists on a single RAS server. But what if you had multiple Remote Access servers? What if you had other devices like network switches, like wireless access points, and you wanted to control access through those devices as well? Well, at this point you might consider installing a centralized authentication and authorization server. Now, because you might have different manufacturers of hardware and software on your network, it's probably best that we install a centralized authentication server based on an industry standard. And in Microsoft, the standard we support is RADIUS. RADIUS stands for the Remote Authentication Dial-In User Service, and there's two main components for a RADIUS system. First of all, the RADIUS client. Now this is the client or device that accepts the initial connection from the user or computer. In our case, the Remote Access Server that's going to accept the VPN connection from the client. When we configure a device like a Remote Access Server as a RADIUS client, instead of using local policies, it passes all authentication and authorization requests onto a centralized RADIUS server. Now, on a Microsoft network, this is an NPS server that acts as our RADIUS server. Now, although we're using remote access, as I said in the previous slide, don't forget that this could quite easily be another manufacturer's piece of software, or indeed a piece of hardware that's challenging the client computer or user connection information and passing that onto an NPS server. The NPS server then is acting as a centralized authentication, authorization and accounting system, a AAA system. What we now want to do in the rest of this video is configure our Remote Access Server as a RADIUS client, so it passes all authentication requests onto our RADIUS server, who will use local network policies to decide whether our users can get access to the network through this VPN connection or not. Here we are back on our Remote Access Server, and what we're just going to do is tidy things up a little bit, just so we can also prove that it's not the Remote Access Server granting connection, but it is our RADIUS server granting connections when we establish the remote access connection to our RADIUS server. So we'll start off by deleting policy 1, so that on this remote access server the only policies available are the two built-in policies that deny access to everybody. Now we'll close down this local policy screen, and just to prove now that the client can't get in, we'll flip back to workstation 1. We'll try and establish a VPN connection, and because we've deleted the network policy, that connection should fail. Here we are back on workstation 1. The VPN connection is disconnected at the minute. If we attempt to connect, again, error 812, the connection was prevented. So we can't get in, the network policy is deleted, that's why. So now we've proven that the connection is broken, let's go back to the remote access server and configure it as a Radius client. So back on remote access 1, RAS 1, we're going to configure this machine now as a Radius client, and to do that we need to go to the properties of our RAS server, and we are interested in the security tab. Now, as you can see here on the security tab, we have two sections: authentication provider and accounting provider. And by accounting, remember, we mean login. At the minute, both the authentication provider and the accounting provider are the Windows defaults, so Windows authentication and Windows accounting. This means that the local remote access server will handle all authentication and authorization requests, and the login, the account information, would also be done locally. We want to change this. I'm going to change both of these settings. So on the drop-down list there, I'm going to select Radius Authentication, and I'm going to say to configure the Radius Authentication properties. Now what we need to configure here are details of the Radius servers that I'm going to pass authentication and authorization requests onto. Now my Radius server is DC1, so I can provide its name, or you can provide the IP address. Now notice on this screen we also have an option for a shared secret. This shared secret should match the configuration that we're about to do on the Radius server, and the shared secret will be used to authenticate the Radius client against the Radius server when it makes connection. On a production network you should use the shared secret. I'm going to leave this blank. Also notice the port number I'm going to use to connect the Radius server on, port 1812. This is the default connection port. If you've changed this port on the Radius server, you would have to change its port number here as well. So if I say OK there, we're going to do a very similar thing for the Radius accounting as well, so that all account information is also stored on the Radius server. So again, dc1.fb.com is going to act as our Radius server, our accounting server in this case. I apologise. And again, if you notice the port 1813 is going to be send account information to the Radius server. Very good. Now that's it on this side of the connection. That's all we need to do. Right now we have configured the RAS server as a Radius client. So now we need to flip to the MPS server, that is our Radius server, and configure the MPS side of this configuration. So we just apply those settings, and while they're applying, we'll flip to our MPS server. So this MPS console, again slightly annoyingly, if you look at the name of the console, it's called MPS local, but this time I've installed the network policy server role onto this machine. So although it is again looking at local policies, these are now policies that could be used to support a whole host of clients. Now the first thing we need to do on this side of the connection, on the Radius server, our MPS server, is identify which Radius clients are allowed to submit authentication and authorization requests and accounting requests to this MPS server. So the first thing I'm going to do is go to the Radius clients and server section, and then under the Radius clients section I'm going to say new Radius client. I'm going to provide a friendly name for the Radius client, and then the DNS name or IP address of our Radius client. Now if we provide the DNS name, it's FQDN, and say verify, it will go for an attempt to resolve the IP address of RAS1. And you can see it's resolved to 2 IP addresses of Microsoft Server 1. So we know it's formed a connection with that machine. Now, if you'd configured a shared secret when you configured your Radius client, we could add the same shared secret into the Radius client configuration on our NPS server. Now, without detailing RAS1 as a potential Radius client, we will not accept authentication requests from that machine. Now, there's lots and lots going on, lots and lots we can configure on this NPS server, but we're just particularly interested at the minute in establishing that initial connection. So we've got the Radius client identified there. Then under policies, we have network policies. And you can see 2 very similar looking policies here. These 2 policies, in fact, are exactly the same as the default network policies on the remote access server itself. Remember, those policies denied access 24/7, and these do too. These policies deny access 24/7. So in order to allow my user access, we must configure at least one network policy. So I'm going to say new, and we'll call this NPS policy 1. Conditions, we're going to say Windows group membership, and identify the WBL staff group. So if the user member of the WBL staff group, and we'll add the date and time condition again. So if the user is a member of this group and it is between 7 and 8 Monday through Saturday, but not on a Sunday this time. So if our user is a member of that group and it's one of those date and times, then again grant access. So we'll grant access. We'll choose the authentication types. We will choose idle times and session times. We will choose encryption levels that we expect people to use. Conditions, permissions, and constraints. And just like before, we need to make sure our policy is high enough up in the list so that it's checked first. Remember, if we have the default policy at the top of the list, then no one's getting in. So now with the Radius client identified as RAS Server 1, with a network policy identified that allows our group in at various times, if we now flip back to our client machine, and we'll see if we can gain access now. So here, back on workstation 1, if we say connect to disconnect, VPN, and connect. So there we go, connected through the VPN connection. Now remember, we're connecting to the same remote access server, but that's now acting as a Radius client that's passing all authentication authorization requests onto the centralized NPS server that's acting as a Radius server. So what next? Well, I would say that understanding the relationship between Radius clients and Radius servers is a vital part of the 7411 exam. Make sure you understand the configuration of both remote access servers and network policy servers and how they work together. Watch the advanced RAS NPS video on this website where we will discuss connection request policies, remote Radius server groups, and how they can both be used to pass on authentication and authorization requests to remote NPS servers. And we'll also discuss network access protection and how that can be used to prove the health of clients connected in. Finally, make sure you study the direct access feature. We've not mentioned that today, although we will be covering it in later material. Direct access is a vital part of your 7411 study. Good luck.